time to switch to next talk given by, I don't know if it's Tom Herring or Salim Massoumi, who's going to give the presentation, the summary of the ACC's ACC activity.
It's
probably
Tom Herring.
Yeah, yeah, Tom. So, floor is yours, Tom.
Good. So, good morning, afternoon, everyone. So this presentation is given by Salim and myself. Salim's at Geosciences Australia, and they're responsible for the operational production of the IGS products at the moment. So the product quality and reliability for 2020, basically for the whole year, product delivery and quality was expected, and there was only a few cases of where we had latency on the rapids due to various often data center interaction problems. So what I thought I would do is just quickly run through what our current oh, I see what you mean.
Yeah, sorry, I didn't want to interrupt you, but yes, what's in, oh, perfect, now we can see the slides.
Yeah.
Thank you.
Sorry, I was thinking that's really good. I can see that presentation. Now I realize it should have been on my other monitor. Okay, so to go back one slide. Okay, so go back further. Yeah, the quality has been there. So there's multiple products produced, and the IGS currently is still in operational products dominated by GPS and Glonass products, and really dominated by GPS. I'll talk about that as we get near the end. The ultra-rapid products, they're produced 4 times per day. They have latencies of 3 to 9 hours, and they include a 24-hour prediction period as well. And the weighted RMS scatter of the predictions tends to be around less than 40 millimeters, and the figures below show the plots going back all the way to the beginning of the ultras back many years ago. And the bottom plot here is just for the last year. You can see the results are very stable. This is the comparison of the ultra rapid predictions with the rapid orbit as we go through, and we'll see the rapid orbit matches the final orbit quite closely. So the next product that's out there is the GPS rapid orbit. And for the rapids, we have a 17 to 41 hour latency. They're produced once per day. We have 9 centers contributing to those, and Wuhan was added in late 2020 as a contributor. And in this plot now, we can see the differences between the different quality submissions for each one of those centers. And then also shown here is this IGC, IGA, and IGU. IGA is the ultra rapid adjusted part, which means that's where data was actually used to produce the result. IGU is the predicted part, and as you can see, that's sitting up around 20 odd millimeters or so. So that's, depending on the latency period you're looking at, up to maybe 24 hours ahead, the orbit is being matched in the prediction to what we ultimately observe later on at around the 20 millimeter level as we go through. And then finally, the IGC is the actual real-time IGS orbit, which is being produced by the real-time working group, which we'll talk later on in this session. The other final product that we do is the IGS finals. These have 12 to 18-day latencies, and they are generated quite differently to the rapid and the ultra-rapid products. These products are really aimed, I think, at the highest quality GPS processing for people doing geophysical studies that want to understand, subtle deformations happening inside of the Earth. The station coordinates in these solutions are not constrained to any particular stations. As we see with all of the ITRF repro results, there's a lot of loading effects which are not explicitly included. There can be other non-secular variations happening in time series positions. So in the finals, the system is simply rotated to align as best it can with the ITRF reference frame itself, and no net rotation and no net translation frame. So there's no mapping of station coordinate errors into other products. Also, since these are produced with a latency of 12 to 18 days, we have second order ionospheric effects that can be applied, meteorological models from atmospheric modeling, et cetera, that can be used. And again, there's subtle impacts on loading estimates through the atmospheric delay modeling techniques used and the results of loading, etc., which again, these final products should be relatively immune to those. The current precision is shown down here in the lower slot, and you can see that the best match to the final is actually the rapid orbit, which is in a sense not surprising. It's using much the same data. And then all of the analysis centers now typically are sitting somewhat below, near or below 10 millimeters. And there's the list of analysis centers as we go through. So that is the final clock. And then we also, sorry, the final orbit. And we also have clock quality products here. And again, you can see most of the centers are sitting around the 10 picosecond level for clocks. And just as a reminder, 30 picoseconds is 9 millimeters of range. So in general, even the worst of the clock centers, which happens to be the MIT one, which doesn't do clocks very well, are sitting around about 9 millimeters for their clock estimates. Now, there's also GLONASS products produced on a routine basis. There's ultra rapid and final products here. And just a reminder here on scale changes as we go through onto the GLONASS products. And so you can see here the ultra rapid GLONASS product is running around 50 millimeters or so substantially worse than the GPS one. And then when we compare to the finals, and again, this scale over here is in centimeters, the MCC, that is the operational Russian-produced orbit for GLONASS, and here are all the individual contributors down the bottom. Again, sitting down at, better than it had been in previous years, but still sitting down at the 20 to 30 millimeter level, worse than GPS. Now, of course, the big actions in the ACC at the moment is trying to generate orbits and clocks for the Repro 3 solutions that are being come through. These are just some initial results being obtained. And here we're now seeing median GPS in 2014, the Repro 3 results matching the centers matching again at that 10 millimeter and better level for most of the satellites. And then in 2018 for GPS, but now we have GLONASS for 2018. And you can see from the color scale, that's again, doubled the color scale here for GLONASS, but still we're sitting around the 20, 30 millimeter level for GLONASS. And the new one is coming in as Galileo, and the Galileo scale now is sitting somewhat more similar to the GPS scale in 2018, about 30 millimeters as the peak RMS, again, dependent on satellite to some degree. And so overall, the Galileo is fitting at a level which is getting very similar to that of GPS as we go through. Now, of course, the big question, which is in the strategic plan for the IGS, is the MultiGNSS combination software. And this is the work that Salem's doing at the moment. And so he's been running a new combination software that will replace the existing operational software and designed specifically to process GNSS combinations. And they've been testing it on the Repro 3 operations as we go through. There's a combination, clock combination currently underway, both by Wuhan University using various techniques. And we plan to integrate, or someone plans to integrate this into the orbit clock combination sometime in 2022. And just to give an example of the Repro 3 orbits from GLONASS and from Galileo, this is over the whole period for GLONASS, and you can see the individual center contributions here. And again, they're sitting 20, 30 millimeters for GLONASS. And then Galileo is sitting down here, typically less than about 20 millimeters in recent years. The early days, there's just sufficiently few Galileo satellites, which make it difficult to do orbits on those. And for the more recent products, up until the start of 21, you can see we're down 10, not quite the level of agreement for GPS, but quite good at the moment. So that is our current status.
Thanks a lot, Tom. Do we have questions?
Looking at the chat now.
Yeah, this is yeah. No, I don't see any question to you, Tom. Anyway, thanks a lot for all this nice news, and and of course we are all awaiting this new combination software. Yeah, for sure.
Yes, that's He'll report on it tomorrow to the governing board.
Yeah. Thanks again.